All right, I wanted to do a really quick video here to cover some odd mathematics beliefs that I've run into um, lately. As I've been working on helping explain some of the many online puzzles that I run into on Facebook and other areas, I keep running into some odd beliefs that have puzzled me, and it's made me wonder about the origins of these and why so many people believe the same incorrect things. For example, the order of operations convention allows for people all over the world to get the same answer to a problem, and there's a pretty well-defined structure. It's been around really since the 16th century. This is something that's very old. I recently have found some scans of old textbooks. I've got one from like William Hart and can't remember the other author offhand. I have scans of it, but first year algebra book from 1912, and it clearly states that multiplication and division should be done before addition and subtraction. So these concepts are not new. Um, not at all. And a lot of people will see multiplication, division, addition, subtraction, and they think they just go left to right because that's the way they learn to read. But that's not the way they were taught math, and a lot of people just forget about order of operations. Um, there's also some confusion around the different mnemonics like PEMDAS and BODMAS. People will memorize the order of six letters and forget, how order of operations works. They forget that there's really only four steps to it. So, that's one of the big things I've run into. The thing just to keep in mind, if you're not clear on it, it's really always been working this way. It's you first solve your parentheses, then exponents, then multiplication or division left to right, your addition or subtraction left to right. And again, those mnemonics, they confuse people a lot because they think there's six steps to order of operations. Someone that knows BODMAS will try to say you do division first, and someone that says PEMDAS says you do multiplication first always. And really, they're the same thing. Multiplication and division is basically the same operation. So really, they have the same precedence, and the same's true with addition and subtraction. Subtraction is just adding a negative number. There's really no difference. So just keep that in mind. There's only four steps. Um, and then the other thing I run into a lot as I solve these puzzles is a lot of people say, well, it depends on how you were taught or what you learned, as if mathematics was somehow subjective and there's different methods of teaching. We're not learning what the best color is to paint the living room, or we're not sitting around talking about which football team has the best passing game. You can argue stuff like that. You can argue politics and or philosophy. You think libertarianism is better than this or that. We're not talking about a subject that something that's subjective. This is there's one method that's been developed, and this thing has been around since some of the very early books on algebra back in the 16th century, and so this is really the only thing that's been taught and the only thing that's been in textbooks. But I will run into people who will say, well, in my day, the answer was this, or when I went to school, the answer would have been this. Before all this new math, the answer would have been this. And the truth is, it's not the case at all. A lot of people will, forget what they were taught, and the scapegoat as well. It's all new math. That's the easy answer. Um, and some of these puzzles on Facebook, I'm not sure how valuable some of these puzzles are. There's always like a gotcha in these puzzles. And, people would be better off just spending their time learning math and understanding math rather than, arguing some of this stuff because it gets pretty heated at times, honestly. But, A lot of these puzzles will have a lack of parentheses. A very common myth, one of the odd beliefs I hear is that, wow, you got to have parentheses or you just solve it left to right. And, there's a large number of people that say that. They believe that, well, they believe they were taught that way, which I seriously don't think there's that many incompetent math teachers out there who would have done that. I mean, you don't throw away order of operations just because you don't have parentheses. Parentheses is just one step in four steps. You look at the four steps. You don't have parentheses? Okay. Do you have exponents? Okay, no. Well, do you have multiplication or division? If you do the multiplication or division, and then you move on to addition and subtraction. And that's really the way that it's been. It's been that way for forever. I wish I could bring up the quote from the textbook I was mentioning earlier. There is a textbook out there that really says that. It comes out and says that. It was written in 1912. There's books older than that say the same thing. So that is actually a myth. Um, another thing I run into a lot is some of the puzzles where there's a popular puzzle about a cow where you buy a cow for 800, you sell it for 1,000. You buy it again for 1,100, sell it for 1,300. Very, very simple problem, and the correct answer to this is 400. It's really easy. You have two different, you bought it twice, sold it twice. Each time he made $200, and so it's 400. But a lot of people will say it's 500, and I've heard people actually say the reason it's 500 is because it only matters what he paid at the beginning, what he sold it for at the end, and everything in the middle doesn't matter. And one reason they'll give is because it's the same cow. I'm really waiting for somebody to explain that one to me, because how does it matter if it's the same cow? It doesn't matter if it's the same cow, a different cow. It could be 3 cows. It could be 20 chickens. I mean, the only thing that matters in this whole problem is that there were two different sales. He bought it once, sold it again. He bought it again, sold it again. There's two different sales. So I don't understand that one. That's a really strange one, but I can't tell you how many people I run into that will give that answer. And another problem is a lot of people will answer. They'll say that he lost $100 along the way and only made 300. Oh well, he earned 400, but he only really profited 300. And what happens is a lot of people are just doing math in their head. They're not really thinking it through. And the only thing they see is that he paid 1,100 the second time, and they automatically think that he lost $100 there, and his profit went down, so he only gets 300. And what they fail to understand is that these sales happened in the past, so he obviously got that extra $100 from the same place he probably got the $800. We don't have any idea how much money he had in his wallet or had in the bank. And it really doesn't matter. I mean, if you work that problem out with any amount of money to start with, you come out with $400. If you sit down and say, okay, let's pretend he had $10,000 in the bank. Well, if you work the math out, you end up with 10,400. So obviously he made $400. So people really don't really think it through. Um, like I said, I wish somebody could explain the faulty logic for thinking it matters if it's the same cow. And I'm not going to go into a lot of more detail on the answer and why it's 400. I do have a separate video, which I'll try to put a link in here for. Um, one of the big issues I've seen is that a lot of people think that opinions mean more than their mathematical skills too. If they believe an answer and they find 10 other people who also say they had the same answer, they think that they're correct just because of that. They don't really have the math skills to actually work it through, but if 10 other people agree, they kind of feel like they have a herd immunity, and they believe they're correct. And also, another thing that is an issue is the reliance on calculators. People will claim both sides of an argument based on a calculator, and mostly based on which type of calculator they're using. First of all, people should understand the difference between the complexity of different calculators. If I have a longer expression, something like an 8 plus 8 divided by 8 plus 8 times 8 minus 8, it really requires a scientific calculator. Those have an internal stack, which basically means it has a memory that's capable of keeping track of successive operations. If you use just a simple Dollar Tree calculator or even the standard calculator in Microsoft Windows, you're going to end up with a different number. You're going to end up with an answer that says 72. And I've seen people answer this exact problem and say, well, my calculator told me it was 72. I pulled out this, calculator I bought at the Dollar Tree, or I, brought up the standard calculator in Microsoft Windows and it told me the answer is 72. So that's got to be correct, and they use that as reinforcement, but that's incorrect. And other people will say, well, if you put it in a calculator, you're always going to get 65. Well, that's only really true if you're using a scientific calculator. So you've got to understand that the calculator, it's got to be the proper calculator that can actually do order of operations and do more than one operation. So in other words, calculator results do not qualify as some kind of gotcha, and there's no conspiracy here about calculators or anything like that. So, there's a lot of good information out there on the internet about understanding mathematics. There's also a lot of bad information. People will start Googling these questions and they'll get responses back, and I've actually had people come back to me and argue with me because they sent me a link from some random blogger. I know one famous one out there is there's a web. I shouldn't even mention the name because it's garbage, but it's some kind of Indian website like a Gadget Grasp or something like that, where some random blogger gives an answer. I think it's the cow problem or the horse problem. I believe it's the cow problem, and he claims that the answer is 300, and he gives some really bad reasoning for it. And people will say, well, this random blogger says it's 300, so it's got to be true. So you've got to, you know, be discriminating and get your information from the right places. That's an issue with people on lots of subjects. I see people in politics or, flat earth or whatever it is. People will bring up all kinds of random somebody on the internet. Somebody said it on YouTube, so it must be true. I did a separate video actually regarding some good and bad sources of information for mathematics and where you can get good info. And really, if you want to break that cycle of ignorance, people really need to know where to look and stop trusting, garbage websites or, bloggers who don't know what they're doing. So yeah, that's really what I wanted to discuss. Just not really solving a particular problem, but just kind of bringing up some of the issues that I've run into and seen, and a lot of the myths that are out there. So just be aware of them.